All right, so what we're looking at here this time out is called maximizing area with a given perimeter. Maximizing area means we want the biggest one with a given perimeter, which means we're stuck with a set amount of pieces. All right, so that's what we're looking at. So we have a situation here where we have a farmer who is bought 22 pieces of fence that are each 1 meter long. We can't split them up to build. Now, this should say a rectangular fence. He wants to get the most for his money, right? So he wants to build the pen as big as possible. What dimension should the pig pen be to maximize the area if we only have 22 pieces? All right, so here's how this question works out. Is that it's a rectangular pen. So I'm going to draw a rectangle here. We have a length and we have a width. All right. Now, how we look at this question is if I draw a little sketch here, the most simple rectangle is if I make the, let's see, whoops. Let's go back on that. Let's make the width down here 1, which means up here has to be 1. Now, what I have to figure out, so there's my width, is what my length is. Well, if I have 22 pieces and I'm using 1 here and 1 here, now I'm down to 20 pieces. And so those 20 pieces got to be split up between 2 sides. And so this side must be 10 and this side must be 10. All right, so I'll put that information in. Now, again, the area of a rectangle is length. I don't know how I'm going to do times here with my computer, but we'll go with times width. All right, put a little dot there. There we go, length times width. And so if I have 1 times 10, the area would be 20. All right, well, let's try another one. So the next one, in which case my width would be 2. All right, so there's my width of 2. All right, so if I have 2 here and 2 here, I've used up 4. If I subtract 4 from my 22 pieces, I have 18 left. But I need that 18 to cover 2 different sides. So 18 divided by 2 is 9. And so this would be a 2 by 9 rectangle. And again, I can find the area, length times width. I got 2 times 9, which is 18. Actually, 1 times 10, messed that one up, didn't I? Glad somebody said something to me. That is actually 10. All right, so we have 18 and 10. All right, so then I look at another rectangle, the next one that would be in line, where I have a width of 3, which means both those sides are 3. All right, so I've used up 6 pieces. If I subtract 6 from the 22 that I get to use, I am now down to 16 pieces. And because I have to cover both sides, 16 divided by 2 is 8. So I have a width of 3 and a length of 8. I multiply those 2 numbers, I get 24. Now, I am not going to draw another diagram here because I have established now a pattern. And so as you see, I'm going to follow this pattern to fill out the rest of my table where I have 1, 2, 3, well, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I can do the same thing for my length. It's going 10, 9, 8. Well, it looks like the next one's got to be 7. Then a 6, a 5, 4, 3, 2, 1. And I can't have a rectangle with a length of 0, so these ones don't even make sense, so we'll cross them out. Well, now what I can do is find my area. Again, because the area is equal to length times width, I have 4 times 7, which is 28. 5 times 6, which is 30. And then a 6 times 5. Well, it's starting to repeat itself because with the rectangle, as I mentioned before, length and width are interchangeable when you have two lengths and two widths. And so this is just a repeat of the one above it. A 7x4, that's a repeat of the 4x7. And so, and the rest of these are also repeats. So I don't need them. And so I look at my table now, and the question asks, what is the biggest area you can have and what dimensions make it happen? Well, the largest area is 30 meters. Oops. Let me move this around. Meters squared, and I'll type that in after. If the rectangle has a width of equal to 5 and a length of equal to 6. Again, we'll put the meters squared in there. There we go. And that right here is our largest possible rectangular pen. There we go. So again, we had to do a few of them, follow the pattern, and complete the table so that we can figure out our largest area. All right, now I'm going to do another one of those, a little bit of a twist. Here we go. So a farmer from Ennismore, which is around my area here, also bought 22 pieces of fence, each 1 meter long, to build a rectangular pen. All right, he plans to build a 3-sided pen beside the river, with the river providing the fourth side. And because pigs can't swim, they're not going to cross that. So what dimension should the pig pen be to maximize the area using only 22 pieces? So again, I'm going to draw a diagram of what we're looking at here. Here's my rectangular pen. All right, we have water on the one side here. All right, and so we have a width over here, a width over here, but we only have one length this time. All right, so what I'm going to do is go over here and draw a sketch and figure out the first 3 to get my pattern. And so the first width I'm going to look at is 1. So a 1 on this side and a 1 on that side. So in total, only 2 pieces have been used up, which means there is 20 left. So I don't have to worry about that fourth side. So my length is 20. And again, the area of a rectangle, because this is a rectangle, it's just that we don't have to cover the side with water, would be 20, because 1 times 20 is 20. All right, so now I'm going to do another sketch, the next one, which would be a width of 2. So I have a 2 here and a 2 here. And so 4 pieces have been used. And if I have 22 of them, well, I subtract 4, and so I have 18 left. So we got 18. All right, let's do one more, right, to see the pattern. All right, so the next width I would do is 3. So a 3 here and a 3 here. And so 3 plus 3, I've used up 6 pieces. All right, so 22 minus 6 is 16. And there we go. All right, so now I've done 3. So now the rest of the table, I'm going to follow the pattern. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know. We'll see if we even need that many. All right. I follow the pattern for my length. 20, 18, 16. We're going down by 2s here. So the next one should be 14. The next one should be 12. Next one here should be 10. 8. Again, going down by 2s. 6. 4. Oh, good. It looks like we cut her off the right spot because you can't have a 0 length. All right, so I've used the pattern to complete the rest of the table. Now it's to find out the areas. And so again, length times width or width times length, same thing. 2 times 18 is 36. All right. 3 times 16, I believe, is 48. Again, just use my calculator. 4 times 14, I believe, is 56. 5 times 12 is 60. This one's easy. 6 times 10 is also 60. 7 times 8, 56. 8 times 6 is 48. 9 times 4 is 36. And 10 times 2 is 20. All right, so if I'm looking for the largest area, because all of these have the exact same perimeter, we got 60 here is the longest. Oh, and the biggest, and so is this. And so we have 2 answers this time. So that can happen. All right, so therefore, the max area is 60 meters squared if my width is equal to 5 meters and the length at the same time would be equal to 12 meters, or width is equal to 6 meters and the length is equal to 10 meters. And again, that is where we have the case of 60 meters squared. That's our maximum area. So again, the key is to fill out the table for the first 3, draw a diagram, make sure you can see the pattern, complete the table, and then write a therefore statement. Sometimes we can have 1 answer, and sometimes we can have 2. All right, so again, easy marks if you know what you're doing. Usually when I mark a test or a quiz,